All right, another kind of transformation of a function is a stretch or a shrink, okay? Stretch means to basically stretch it taller or stretch it wider. A shrink means to press it down from being taller to shorter and to press it in sideways to be thinner, okay? And so we can have a vertical stretch, that's a vertical stretch, or we can have a vertical stretch, or we can have a vertical shrink. A vertical shrink would be when you crush it vertically. A horizontal stretch would be where you stretch it out wide horizontally, and a horizontal shrink is where you take the function and you press it together horizontally. And what I've written here is I've identified what you have to do to f of x in order to cause g of x to be either a vertical or horizontal shrink or stretch. Now, in order to understand what I've written here, I need you to understand what we're dealing with. So we're dealing with factors. What we're doing is essentially multiplying some part of f of x by a number, by a factor, okay? And that factor is either going to be greater than 1, like a number like 2 or 25 or 150, or it can be a factor that's less than 1. Now, when I say less than 1, I mean less than 1 but greater than 0, a positive factor that is less than 1, like 0.5 or 0.12 or 0.0003, okay? And so here's how it goes. If you want to be able to identify or to be able to shrink a function vertically, so if g of x is going to be a vertical shrink of f of x, all you have to do is multiply the function f of x, the whole function, by a factor that's less than 1, like 0.5 or 0.1 or 0.4 or 0.7 or something like that. So if you multiply the whole function by a value that is between 0 and 1, then what will happen is it'll vertically crush together, okay? But if you want to stretch it vertically, if you want g of x to be a vertical stretch of f of x, then what you'll do is you'll multiply the whole function f of x by a factor that's larger than 1, like 2 or 5 or 10 or 150, okay? And so what that'll do is that'll stretch the graph vertically, okay? If you want to shrink horizontally, if you want g of x to be a horizontal shrink of f of x, that means you're crushing f of x together into a smaller space, maybe a smaller domain. Not really, but I mean, it looks crushed closer. Note, remember, with horizontal transformations, we only affect x, where with vertical transformations, we affect the whole function f of x. So here, we multiplied by the whole function, but in a horizontal transformation, we're only going to multiply by x. Well, to get a horizontal shrink, you're going to multiply the x by a factor that's larger than 1. So don't get this mixed up. Look, a vertical shrink is a factor less than 1, but a horizontal shrink is a factor greater than 1. And then, of course, for a horizontal stretch, it's going to be a factor less than 1, like 0.5. So we would multiply 0.5 by just x. Now, it's important to understand that when we do this, when we multiply it by just x, if I said that f of x was equal to x squared minus 3x plus 2, then f of 0.5x would be 0.5x then squared minus 3 times 0.5x and then plus 2. You have to change all of the x's that are in the function to the 0.5x in order to correctly accomplish your horizontal stretch, okay? And it would be the same thing with the horizontal shrink, okay? And so what we'll now do is we'll look at all 4 of these examples in Desmos. Okay, so what we're going to look at here is going to be first a vertical stretch, then a vertical shrink, then a horizontal stretch, and then a horizontal shrink, okay? So the vertical stretch means that we multiply the function. So here's the function, x minus 2 times x minus 1 times x plus 2 times x plus 1. Well, if we come down here, do you see this right here? Here's the function, and then we're going to multiply the whole thing by a factor greater than 1, by 2. So when I activate this one, you'll see, look at that, it's vertically stretched. This point, let's go ahead, has gone up here. Instead of 0.4, we got 0.8, and it's multiplied by 2. It's a factor of 2. The 4 times 2 became 8, right? And look at this. This negative 2.25 became negative 4.5, okay? And so we have the positive points became more positive, the negative points became more negative, and so we're vertically stretched, okay? Now let's look at a vertical shrink, okay? So that means we have to multiply the whole function by something smaller than 1. Well, look at this. This right here is 0.4. 0.4 is less than 1, and when we multiply it by the whole function, it should vertically shrink the function. And look at that, it really does. It's a factor of 0.4. 0.4 times 4 is 1.6, and so look at this. We got 4, so this should be, look at that, 1.6, okay? And this negative 2.25 becomes negative 0.9, okay? And so the high points became lower, and the low points became higher, okay? Or the negative points got closer to the x-axis, and the high points got closer to the x-axis also, okay? If we made this even thinner, we could actually almost flatten it out. Look at that. If we just keep making it thinner, it just becomes flatter and flatter and flatter, because it's vertically shrunk until it becomes a pancake. Okay. All right. Now let's do a horizontal stretch. So we're gonna stretch it out horizontally. So this point is going to be pulled way out here. This point is going to be pulled way out here. And so what we have to do is we have to multiply each individual x by a factor smaller than 1. So look at this one right here. I'm multiplying the x by 0.4. This x is being multiplied by 0.4. This x is being multiplied by 0.4. This x is being multiplied by 0.4. And when we activate it, you can see, look, it's stretched way out. Look, we can't even see this one over here, okay? In fact, if I make it a little less of a stretch, let's maybe make it 0.6. We'll go 6, 6, 6, and 6. There we go. That's a little bit better. So when we do a factor of 0.6, you can see this is the original, and the new one is stretched out horizontally. Okay. Now let's do a horizontal shrink. Okay. And to do that, we're going to multiply each x by a factor larger than 1. So we're going to multiply them all by 2. So 2x, 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 2x. And when I activate that, you can see that it's stretched inward. And if we multiply them all by, let's say, 200, look at this. It's going to be a little crazy. Oh, it's 2,000. Let's do 200. 200, 200. Look at that. It basically got squished so far together, it's basically a vertical line. Okay? And so the larger the factor, the larger the shrink, okay, and until eventually it just squeezes together into what looks like a line, okay? All right, so that's it for vertical and horizontal shrinks and stretches.